Okay, so today we're talking about roots of powers and powers of powers, exponents and their opposites, the roots. Like a square root is an opposite of a square, and you use them to cancel each other out. There are a lot of different ways you can have this happen with numbers, and each gets handled on a calculator a different way. For example, the first one up here in the top is the most straightforward because that's just going to require you to find the square root key of whatever calculator model you have and punch in square root of 36 and hopefully just equal 6. The square root of 36 is 6, straightforward. You may even have known that based on the fact that 6 times 6 is 36, and most people know those times tables. It gets harder when you start talking about third roots, because now you're asking yourself what number times itself 3 times is going to give you the correct answer. Now, on a TI-84, which is the model of calculator I personally use, let me pull that up here, hang on. You are going to see the math button. It's right underneath the alpha. Actually, the picture cut it off slightly, so that button would be right down here. When you hit the math button, it brings up this menu. You will notice a lot of things on this menu, and a lot of times you're going to want to come back to it, but for today, we're just looking for the fact that the fourth option here tells you third root of, and that's how you would calculate this answer. So if you were to type in third root of 64, you would get 4, because 4 times 4 times 4 is 64. And again, up here we've got fourth root of something, which requires yet something else. On that same menu on your calculator, you'll notice that underneath it this time, we've got number 5, which is x root. So the way you would deal with that question is you would type into your calculator the 4, so you had what root you're looking for. You would hit math and pick the 5th option to get that, and then you would type the 81 to discover what the 4th root of 81 is. And with any luck, you should have come up with 3, because 3 times 3 times 3 times 3 is 81. Now, what do you do if it doesn't have numbers and it has variables with exponents instead? What you've got here is no numbers at all, so you're looking to simplify this. Simplifying it means getting as much out from under the radical sign as humanly possible. And to do that, you kind of have to think in terms of what does a to the third and b to the fourth mean? Well, a to the third means a times a times a, and b to the fourth means b times b times b times b. And as you know, or should know by this point, hopefully you know this, if not, listen carefully, a times a is a squared. And as I mentioned earlier in the video, squares and square roots are opposite of each other. So if you square root a times a, basically you get a single a outside of the radical sign. This poor guy doesn't have a pair, so he's going to have to stay behind. And the b's, I have 2 pairs of those. So I'm going to be able to pull a pair of b's out, and that's going to be b squared. So the way this would write with a single a and 2 b's coming out of it, and this guy left over, the way that gets written is ab squared on the outside times the square root of a, because this poor guy is forever alone and gets stuck back underneath. So that's how that gets dealt with. You're pairing them off. Now, you may have another complication on top of that. So let's look at the next problem. All right, if you have a third root or a fourth root or a fifth root or whatever, when you do that breaking out thing, and of course I don't want to have to write all this out, but I'm going to. There are 5 x's under x to the 5th power, and there are 6 y's for y to the 6th power. 1, 2, 3, 4, 5, 6. So the problem is now that this is a third root. That means instead of pairing these off to figure out what comes out, it's going to be groups of 3 that determine whether things come out. So in this case, I've got 3 x's, a group of 3 y's, another group of 3 y's, and those are the things that are going to be able to come out of this. So I would express my answer as x, y squared, because I have 1x and 2 y's. I'm going to slap down my third root symbol, and then these poor guys are what's left, so I'm going to stick a x squared back inside that. Now, there's another way you can think about this rather than having to write all this stuff out. Erase all this really quick. Hold on a second. Okay, going back to the beginning, you can think about how many groups can come out without actually writing all that out. If I'm looking at 5, I can be pretty well assured that I can get one group of 3 out of that, and chances are, you know, if you take 3 away from 5, you're going to have 2 x's left over on the inside. And then if I look at 6, I can take 2 groups of 6 out and not have any remainder left on the inside, and I'd be done with it. So you don't have to write it all out. You can if it's helpful. If you know your times tables or division with remainders, that's your faster bet. 5 divided by 3 is 1 on the outside, with a remainder of 2 on the inside, and you're good to go. Now, easier to deal with is powers of powers. So in this case, I've got x squared to the 3rd power. And again, talking about what x squared means, that's x times x, right? And if I take x squared to the 3rd power, that means 3 groups of x times x. And that's 1, 2, 3, 4, 5, 6 x's. Wow, that's terrible. Cover my shame there. So my final answer for this would be x to the 6th power. Even easier to think about is scooching all this off to the side. All I need to really do is multiply those 2 numbers, and that tells you what my answer is. X squared to the 3rd power is x to the 2 times 3 power, which means x to the 6th power. And that's the easy way to do this without having to write all that stuff out. So that is roots and powers of powers. It doesn't really matter if I were to have, let me try one more thing. If I were to have x squared y to the 3rd to the 4th power, you just got to make sure you multiply this guy by both parts there. So x to the 2 times 4, y to the 3 times 4. So my final answer would be x to the 8, y to the 12th. And it doesn't matter how many letters you throw out there, it's going to operate the same way. So hopefully that made sense, and feel free to comment or email me if you have a question or if something wasn't clear or you see an error, and I will be happy to address that. Thank you for your time. Bye.